Hi, welcome to the Chicago Math Lab, the differential equation problem solving section. So today, this is the problem we're going to solve. It's 35y minus 1 over x dx plus dy over y equal to 0, okay? With the initial condition, the y the square root of 2 equal to square root of 2. Okay, so let's first take a look. And before we decide which method to use, I typically like to rearrange the equation a little bit to see I can find a better way to look at. So the first, I like to put a dy dx together. So I would like to divide by dx both sides here. All right, so I have 35y minus 1 over x is plus the 1 over y dy dx equal to 0. Okay, so the dy dx. Now the next thing is here, this 35y minus 1 over x here. What I like to do, I would like to combine it. So this will be x common denominator. So the first term will be 35y xy. Maybe I'll write it into the xy is better. Okay. So here it will be 35 xy minus 1. Okay. So then this is kind of this is 1. Then I will do here, this is a plus. Okay, so this will be plus 1 over y. Okay, so that's so plus 1 over y dy dx equal to 0. Then I typically like to single out dy dx. So I multiply by y both sides. So when I multiply by y, I don't like to have anything in front of my dy dx. So that's why times y both sides here. Okay. So now I will have my first term going to be x y, right? Then this will become 35 xy minus 1 over x, okay? And plus dy dx equal to 0, okay? So now the next things here, I will, the kind of, I want to take a look to see I be able to put into a linear terms or not. So I like to, the factor that out and see what happens here. All right, so this is 35xy minus 1. Oh, okay, so here, see here, I'm not careful. So this is 35xy. So this is minus 1 here. All right, so I need to be very careful here. All right, so then I will be FOIL that out. Okay, so take a look here. So then here, for first term is y over x 35 xy. So xx can cancel. So my first term turns out to be 35 y squared, right? So then the next terms here can be, so it will be minus 1 over x to the y plus dy dx. Well, my eyes just widened it up. Why is here? Because this is kind of a perfectly conditioned match my what? The Bernoulli equation. So let me rewrite this and then you will see. So this is a dy dx minus 1 over xy. Then move this negative 35 to the other side of my equation. So remember, what is my Bernoulli equation looks like? my Bernoulli is dy dx plus px y is equal to qx y to the n. So here I got a pretty good matches here. So this will be my px, and then this is my qx, negative 35, right? So it's qx, and then my n's here is 2 here. Great. So I know as soon as I manipulate this equation and it turns out to be a Bernoulli equation, then I know I'll be able to solve it by using the Bernoulli equations process, right? So what is the first process? We did this many times. So step number 1, I will assign the v is equal to y, the 1 minus n, because n is 2, so it's y 1 minus 2 is y the negative 1, so it's 1 over 1. Okay, then the second step, like always, what I need to do, I need to take the derivative, right? So dv dx, the y to the negative 1, so it's negative y to the negative 2, dy dx. Okay, so what is the next one? We want to single out the dy dx, right? So I want to just dy dx by itself. Now I can substitute to this equation. So let me let me highlight this equation. This is our first equations here. All right, so then the v, okay, so we need to highlight those important information. So this one's here, so I can just times negative y square, both sides here. All right, let's take a look. So this will be the dv. So this will be the dv dx negative y square is equal to, so the dy dx. Okay, so my dy dx is equal to the negative y squared. So what I need to do, I need to substitute this dy dx to here. All right, so this is my step number 3. We always follow the same step. All right, so dy dx is here, I substitute to here, so it's a negative y squared times dv dx minus 1 over x y equal to negative 35 y to the square. Okay, so now what is the next one here? I want to single out the dv dx, right? So I divide both sides by negative y square, negative y square. Okay, so when I do that, what I have here, so that this will be dv dx. Okay, then the negative become positive. Then y had 1, so I have 1 over x to the what? 1 over x to the y's here, right? So I have 1 over x and I have y here, right? And that is equal to negative positive, so 35. Okay, and then as I highlight here, the y is equal to 1 over y equal to v. So finally, we write this equation is plus 1 over x times v equal to 35. Okay, so after this one, so we should be very familiar with Bernoulli. What is the next step? It's step number 4. Right, so we want to find the integration factor. So the integration factor, we always said du dx is equal to, and this is my new px here, right? So dv dx, so will be equal to the 1 over x times u. Now I want to solve for u. Okay, so this one's here, we can do a switch. So this will be the du over u is equal to the dx over x. So when you take the integration both sides, I got the natural log of u equal to the natural log of x. So I will say u equal to x. Okay, very good. After I do that, then let me highlight, this is my second important equation, right? So this is the one. Okay, so now after I find my integration vector, then the next step is what? Multiply the integration vector to this equation. So that means the x times dv dx plus 1 over xv is equal to 35 times x. That's right. So I times x both sides here. Okay. So this one's here. So this one will give me x dv dx plus b equal to 35x. So remember that. So what is this one here? This is the one equal to the derivative of x of the what? X times the u times. So this is will be the x times v. So if you take the derivative, product rule, so it's x times dv plus v times derivative of x. So I know I did it right here. So this will be 35x. Okay, now the step number 6 is here. You integrate both sides. Right? So you integrate d, the dx, xd, and equal to the integrated 35x, the dx. So this is the derivative of xv, and you integrate it. So by the fundamental theory of the calculus, so we know this one is xv. So 35x squared. So it says 35 over 2 the x squared plus c. Right. Very, very good. So v, let's see. Do we remember what is our v? V is 1 over y. Right. So okay. So I replace. Replace the v with 1 over y. So it's x over y is equal to 35 over 2 the x squared plus c. All right, so now I need to solve my c. So my initial condition is 1 over the square root of 2 equal to the square root of 2. Okay, so that means, okay, I plugged it in. So x equal to the square root of the 2, y equal to the square root of the 2 is equal to 35 over 2. Then the square root of the 2 the square plus c. All right, so this one's here 2 and 2, so this one will be 1, and this one's here going to be 35, right? So we find 1 plus, okay, so we find the y equal to 35 plus c. So what is my c? C is equal to negative 34. Okay, now finally, last step, substitute back c. We can find our solution. So our answers here is x over y is equal to 35 over 2 the x squared minus 34, right? Minus 34. Now I can divide by x both sides. Okay, so I divided 1 x both sides. So this one will be 1 over y will be equal to 35 over 2 to the x minus 34 to the x over the x's, right? Now I flip the y, so the y will just be 1 over 35 over 2 the x minus 34 over x. So this will be our solution. So for this problem, if you look at the initial, it looks like kind of complicated. But then, like I said, I always will try to manipulate my function a little bit, equation a little bit to see if I be able to spot some patterns here. All right, I hope that this one can help you to do your homework. Okay, have a good day and talk to you in our next sections here. Okay, bye.